in 100 division it measures 1 volt. So 1 volt in 100 division. Now explain how the instrument can be used for measuring up to 300 volts. So volts per division is actually 1 division we will have 1 divided by 100 or 0.01 volt. So now what we want that the full scale of this ammeter should measure 300 volts. So from 1 volt we want to convert it to 300 volts, and we are already having its internal resistance. So R is 100 ohm. So for 300 volts, if we divide it by 100 ohm, we will get 3 ampere. So for this structure, if we apply 300 volt across it, we will have 3 ampere current flowing through it. So this will definitely damage this circuit. So now what we want that in 150 divisions it measure this 300 volts. So we are having 50 extra divisions in it. So for those extra divisions we want to calculate the RSC. So how will we calculate this RSC? The voltage across the meter producing a full scale deflection is now 150 multiplied by 0.01. For 1 division it is like 0.01 also. For 150 it will be 1.54. So we want this 1.5 to be across this system. So for that 1.5 we are having our resistance as 100. So we can calculate the maximum current that can it bear. So 1.5 divided by 100 is the maximum current that it can bear. And now this is our IM, and our RM is already 100 given. This V is given. V is what? V is 300, the maximum current, and this IM is given as 1.5 divided by 100. So 1.5 by 100, 1.5 by 100, and we got our AC equal to 19.9 kilo ohm. So this is what we were solving. Let's summarize it. Let's delete all these things. Let me delete these things as well. Okay, so we have full scale like this, and here it is 100 division and here it is 150 division. The problem says that the total resistance is 100, and on 100 divisions it measures 1 volt. So for 1 division it measures 0.01 volt. For 150 division it measures 1.5 volt. So now we can calculate the amount of current that will be required for making this much deflection on the needle. So I is equal to V by R, which is 1.5 divided by 100, which is 0.015, which is 15 milliamperes. So 15 milliampere is our IM, the current that this system can bear, the maximum current of galvanometer. So now we are having this situation that we want to convert it to 300 volt based ammeter. So 300 minus IM RM divided by IM would be our RSC. So RSC, put the value of IM, RM and IM again, and you get 19.9 kilo ohm. So this is the solution. I hope you have understood it now. Okay, in this problem we want to convert a galvanometer to two different things, a voltmeter and an ammeter. A voltmeter that can measure 50 volts and an ammeter that can measure 10 ampere. So we are having this formula that RSC is equal to M minus 1 into Rm and M is equal to V by Vm. V is 50 here because we want to convert it to 50, and Vm is 10 millivolts, or M is calculated as 50 divided by 10 millivolt. Okay, and Rm is given for this voltmeter, so Rm is also given, so RSC is calculated by 50 divided by 10 power minus 3 minus 1 multiplied by this 5 ohm. So this turns out to be this. Now we want to convert it to an ammeter that can calculate 10 ampere. So we had this 10 millivolt as Vm. We do not have Im. So for this B part, we will first calculate Im. So Im is equal to Vm divided by R. Vm is what? 10 milli divided by R. R is 5. So Im turns out to be 2 milliampere. Now we can use this formula. Rs is equal to Rm. Rm is 5 ohm and M is I divided by Im for ammeter. So I is this 10, which will be the final full scale voltage, and Im is the initial full scale voltage. So initial was calculated to be 2 and the final is given for the problem as 10. So 10 by 2, 10 power minus 5. So Rs is calculated by this Rm divided by M minus 1. So this turns out to be 1 into 10 power minus 3 ohm. So if we introduce such shunt with it, this will then be used for calculating this 10 ampere. In these 10 amperes, what will happen? 2 milliampere will flow through this ammeter at full scale deflection, and the remaining 10 minus 2 milliampere will flow through this. So this will not burn for up to 10 ampere. If this the current goes to 11 ampere, it will definitely burn them. So this mechanism is for 10 ampere now. This is another example. In this example, it is stated there as PMMC is having resistance of 75 ohm. So 75 ohm is the given resistance for a full scale of 100 division, and current on the full scale is 1 milliampere. So 1 milliampere is the maximum bearing current at this branch. Okay, the combination is then connected to a series load. What is the current in the load when the instrument gives an indication of 80 milliampere? So we are having this RSH, and we are being told that if these are 100 divisions, then at 80 divisions that is given for this at this point, what is the current that is flowing through this? So for that, one must calculate the per division current and then multiply it by 80. So 80 division is the covered area, and current through this one division is calculated now. So we are given with this 25 ohm resistance, which is connected in parallel with it. So the total current is now 0.8 milliamps that is passing through this voltmeter, this galvanometer branch. So let's use the current dividend rule to calculate the total current that is going inside this circuit. So this current is 0.8 this is unknown, and this is to be calculated, but these are SH and all the stuff are known. So we can say that branch current IB is equal to the resistance in which it is not flowing divided by resistance in which it is flowing plus not flowing multiplied by the total current. This branch current is 0.8. The not flowing side is 25 milliampere current in which it is not flowing. So here it is not flowing. So 25 divided by flowing plus not flowing. So flowing resistance is 75 plus 25. So this turns out to be 100. So this is 25 divided by 100 multiplied by I is equal to 0.8. So I turns out to be 3.2 milliampere. So this I that is going inside it is 3.2 milliampere, which is the same current as the load is using. So this was an interesting example in which we used the current dividend rule for calculating this total current. PMMC to ohm meter conversion. This is a very interesting topic. In this topic, this mechanism starts behaving in reverse. First of all, we should understand that in the previous ammeter and voltmeter, we already had current or voltage. So these are the form of energy. Now, if we connect any resistance with it, we do not have any energy. So without a cell, this mechanism will not work. Also, if this resistance is open, so it should give us infinity resistance. So we mark this circuit, this side as infinity, and if this circuit is closed, so it should give us zero resistance. So this maximum scale is given as 0. So when we do not connect any resistance with it and do not short circuit the terminal of an ohm meter, it will show us infinity ohm resistance at 0 degrees. So this is obvious. Okay, we install a battery here, and after that we install a resistance here and make this resistance equal to this resistance. So if this resistance is equal to this resistance, what will happen? The voltage will equally divide in these two things, and thus the current deflection will become half. So we can say that, let's say this is 10 ohm and this is 10 ohm. So at half we say that this is 10 ohm, this side is infinity and this side is 0. So now between 0 and 10 we can graduate it as well. So this is the mechanism. Further you can study this topic in this link. So this is the general mechanism of conversion. Okay, let's move towards the next topic, the electro dynamometer type instrument. Before this topic, we studied all mechanisms that were having a static field of magnetism, and we were having DC values. So for DC the direction do not change. But what if this thing is an AC? So in that case the direction of this PMMC would be same, EMM would be same, and this coil would change with respect to time. So this will not let this needle to move in either direction. So for that we use these magnets as coils, and uses the same energy which we are using for the excitation of the coil. So if this energy in this direction, this will produce this field. If this energy is in this direction, this will also produce opposite field. So opposite multiplied by opposite, negative multiplied by negative will also give us a positive direction. So in both cases we would have a same direction. In the PMMC type, if the direction changes, so one remains constant and other remains changed, so the direction reverses. But in EDM we are having minus minus both, so this gives us the same direction. So this is the theory of electro dynamometer, which is used for both DC and AC. So PMMC is used for DC, EDM is used for both AC plus DC. So remember these things. Okay, this is it. This is the end of this chapter. I hope you people have got an idea of how electro dynamometer type instrument and electromechanical instrument works. Okay, thank you. Thanks for listening.